Welcome to another edition of the Carolina Bay of the Day, where we study the secondary impacts made by the glacier ice boulders that were ejected by one or more extraterrestrial impacts on the Laurentide ice sheet. This presentation examines the differences between the Carolina Bays on the hard, hilly terrain of the Piedmont and the Carolina Bays on the flat, sandy terrain of the Atlantic coastal plain. The word Piedmont comes from the Italian words for foot and mountain. A Piedmont is an area at the base or foot of a mountain. In the United States, the Piedmont is a plateau region located between the Atlantic coastal plain and the main Appalachian Mountains, stretching from New York in the north to central Alabama in the south. The Blue Ridge Mountains are a geographic region of the larger Appalachian Mountains range. The Blue Ridge extends from southern Pennsylvania through South Carolina. The name Blue Ridge is well deserved. The mountains take different hues of blue in the morning when the sun rises. The fall line is the boundary where an upland region and a coastal plain meet. The boundary between these two regions is typically prominent where rivers cross it, with resulting rapids and waterfalls. The uplands are relatively hard crystalline basement rock, and the coastal plain is softer sedimentary rock. The Atlantic seaboard fall line is a 900-mile or 1,400-kilometer escarpment where Piedmont and the Atlantic coastal plain meet in the eastern United States. Water transportation was the cheapest and most reliable method of moving goods and people in the early years of the country's development, so it was natural that areas near fall lines and rivers often became population centers. During the colonial era of the United States, the fall line was generally the head of navigation on rivers due to the rapids or waterfalls and the necessary portage around them. Numerous cities initially formed along the fall line because of the easy river transportation to seaports, as well as the availability of water power to operate mills and factories, which brought together river traffic and industrial labor. The Potomac River flows along Georgetown in the District of Columbia, which is situated just below the falls. The Chesapeake and Ohio Canal, or C&O Canal, along the Potomac River established a system of locks that made it possible to navigate westward beyond the fall line. Some of these locks still work today. The National Park Service maintains 184.5 miles of trails along the C&O Canal. The trails are used by hikers and cyclists. Picnic facilities are available at many places along the route. In downtown Georgetown, there are boat tours in the first mile of the C&O Canal National Historical Park. Visitors learn about the technology and culture of the canal and the interesting stories of the people who lived and worked there over the past 2 centuries. The sidewalks along the canal can be used by pedestrians to reach many of the restaurants and shops in Georgetown. This LiDAR image of North Carolina includes the city of Raleigh. I have drawn a yellow line to separate the Piedmont from the Atlantic coastal plain. The rough terrain of the Piedmont is mostly gray, whereas the Atlantic coastal plain is dominated by large areas with the same color or with gradual color transitions that correspond to areas with the same topographic elevation or slightly inclined terrain. Today, we will be examining Wilson's Bay, which is one of very few Carolina bays on the Piedmont. Bliley and Burney published a study of Wilson's Bay in 1988. Using radiocarbon dating, these authors say that the onset of the bay's open water phase occurred at least 22,000 years before the present. The gravel rim sediments were attributed to ice push activity, as have been described along the shores of modern lakes in the northern US and southern Canada. The authors believe that the distinct sandy rim unit is partly Aeolian in origin, deposited by strong southwesterly winds, but then they say that initial bay expansion did not correlate with the southwest wind component. Overall, the paper by Bliley and Burney describes a confusing picture of an open water lake, moraines deposited by glaciers, and sand deposits that are inconsistent with the geological history of North Carolina. Since the discovery of the Nebraska rainwater basins in 2001, there is increasing evidence that the Carolina Bays are impact structures. The glacier ice impact hypothesis, published in 2017, proposes that one or more extraterrestrial impacts on the Laurentide ice sheet by the Great Lakes ejected pieces of ice in ballistic trajectories. The secondary impacts of the glacier ice boulders produce seismic vibrations that liquefied on consolidated soil, and the oblique impacts created inclined conical cavities that became shallow elliptical basins by viscous relaxation. Today, Wilson's Bay has some forested areas and farm fields, but there is no evidence of a lake. Many bays were drained during urbanization, so it is not possible to know for sure if this bay was originally a lake. Michael Davies, who is the author of the LiDAR visualization tool for Google Earth, interprets Wilson Bay as two overlapping bays of typical proportions. There's a link to the visualization tool in the description of the video below. It is important to notice that the points that are on the well-preserved perimeter of Wilson Bay can be fitted with an ellipse using the least squares method. This conic section corresponds to a cone inclined at 58 degrees. The Piedmont is characterized by uneven terrain. The center of Wilson's Bay is at an elevation of 73 meters above sea level, but the area to its northwest is several meters higher. During the period of viscous relaxation, immediately after the formation of the impact cavity, liquefied soil from the higher elevation flowed into the cavity and distorted the elliptical shape as illustrated in the inset figure. This deformation mechanism is also observed in some Carolina bays on the inclined banks of the Savannah River in South Carolina. Although it is possible that a glacier ice projectile impacted at an angle of 58 degrees, there may be another explanation for the circular shape of the bay. The Piedmont consists of hard terrain and the unconsolidated ground is not very deep. The impact of an ice projectile on terrain that does not have a deep layer of unconsolidated soil will result in the disintegration of the projectile when it reaches a hard layer. This will produce a more circular impact basin. These circular Carolina bays are also present in the Delmarva Peninsula, which has a low depth of unconsolidated material. 35 million years ago, a meteorite impacted the eastern shore of North America, very close to this point of Chesapeake Bay. The resulting tidal waves removed much of the unconsolidated ground in this region. Evidence of the extraterrestrial impact was discovered during drilling operations in Chesapeake Bay. Scientists calculated that a bolide with a diameter of 3 kilometers impacted at a speed of nearly 60 kilometers per second, punching a deep hole through the sediments and into the granite continental basement rock. The bolide itself was completely vaporized, with the basement rock being fractured to depths of 5 miles or 8 kilometers, and a peak ring was raised around it. The deep crater, 24 miles or 38 kilometers across, is surrounded by an outer edge of collapsed blocks forming ring faults. The crater was then buried by additional sedimentary beds that have accumulated during the 35 million years following the impact. When we digitize the points along the perimeter of the Carolina bays on the Delmarva Peninsula, we can verify that these bays have elliptical geometry. The width-to-length ratios of the bays in Delmarva are similar to Wilson Bay in North Carolina. The circular shape of the bay may be attributed to the shallow depth of unconsolidated material. Going back to the same area of North Carolina near Raleigh, we can see that the Carolina bays on the Atlantic coastal plain have the familiar, narrower elliptical shapes. Fitting these Carolina bays with ellipses, we find that they correspond to cones inclined at 42.3 degrees. Many of the bays along the Atlantic coastal plain have width-to-length ratios corresponding to cones inclined at 35 to 45 degrees. This model illustrates the formation of a Carolina bay by the oblique impact of a glacier ice boulder on viscous ground, followed by viscous relaxation and melting of the glacier ice. The ice ejected by an extraterrestrial impact on the Laurentide ice sheet would have been evenly distributed within the 1,500-kilometer radius of ground zero. This is a reasonable assumption based on the density of the Carolina bays on the Atlantic coastal plain and in Nebraska. If this is so, the Piedmont in North Carolina would have been as heavily bombarded as the coastal area. The fact that there are so few Carolina bays on the Piedmont terrain tells us that in general, the Piedmont terrain was not suitable for the formation of the penetration funnels that formed the bays, and that any bays that formed on the uneven terrain were quickly eroded. Thank you for joining me in the investigation of the Carolina bays and the Younger Dryas Cataclysm. I will continue to examine the mechanisms that made the Carolina bays based on the principles of experimental physics and thermodynamics. My book about the Carolina bays is available at Amazon. Please subscribe to my YouTube channel to be notified of future videos about the Carolina bays and other scientific topics.